So let's just recap what we have here. We have our loading page, and we have our home page. The save button doesn't work yet. We had view database using table, so we had a bunch of table entries come up. We did do the event handler for the table, so we got that done. Get back, go to the picker. We have nothing for the picker. So what's left to do for this app? Get that picker up and running, and also get this save button up and running and insert into the database. So this is the two remaining tasks we have left to do in this app, and then we're done. So let's start with the picker. Let's get that up and running. That seems the easiest to do. So we're going to move over to picker view controller.h. And we're going to start configuring this picker. So in picker view controller.h, we need to bring in a couple of delegates here, or a couple of interfaces. So we're going to bring in UI picker view data source and its delegate. And a couple more variables. So we need an IB outlet to the picker itself. We'll just call it picker. And what we did last class was we defined app delegate here in the table, the table.h, and it was very convenient to just get that out of the way. So let's do that here as well. So say app delegate. Of course, that'll involve including the header file for it, but we'll do that in a sec. Main delegate. And I'm going to bring in app delegate.h as well. And do our property declarations. All right, and that's our header file. Now, with the picker itself, you're going to find a lot of consistencies with the picker that you found with the table. A lot of the methods that we implemented in the table to configure the table are also similar in style to how we're going to implement the picker. And you'll find you'll be sort of right at home with dividing the picker. In fact, you'll find it even easier to work with the picker than the table. So we're going to start off in the M file by synthesizing our stuff. So we'll say synthesize, and we have picker and main delegate. And let's start off by configuring the app delegate. So we'll go into view did load. We'll say main delegate is equal to app delegate UI application shared application delegate. And what we want to do is we want to get the latest and greatest, the freshest copy of what's in the database. So let's just do a call to main delegate, read data from database. All right, so we'll have the latest info. The reason being is because right now we only call it inside did finish launching. And if we were to insert something into the table and hit that save button and then all of a sudden go to verify it's there by clicking on the label to view it in the picker on the home page, then you wouldn't have the latest. So we want to make sure we have the latest here. And so that's why we're doing it here. So with view did load, we have our latest copy of the database. I'm going to do a couple of pound pragmas just to organize my code. So let's say pound pragma, mark, view methods. And I'm also going to do one for picker methods. So pragma, mark, picker methods. All right. So I have my picker methods, and with the picker, you're going to find that the methods I'm going to call right now are very similar in style to what we worked with the table. So there's 4 main methods we care about, really 3, just like with the table, really 3. The fourth one is like the event handler for the item, right? So the first one being how many items are there in the picker. Now, what do I mean by that? Well, there's 2 ways to approach it, and there's actually 2 methods. One is, well, how many rows are there in the picker, which is what we had in the table. The second one is a bit different because in the picker, we have the option of having more than one spinner inside the picker. And if you look at the date picker for as a prime example, we had month, day, year, hour, minute, second, day of the week. All of those spinners were in the same picker, right? So that should give you a bit of an idea that with the picker, you can have multiple items inside the same picker. And so we have to tell it how many items we want in the picker, how many columns we want in the picker. So we're going to define those two methods. But there was a method in the table that said how thick is each cell for the table. In the picker, that's a standard thickness, so we don't define that. So we don't define the thickness. So that's the trade-away, is that we don't need that method. So let's start with those 2 methods I just mentioned. First is how many columns are we going to have in this picker? So its return type is NS integer. We'll start by typing out picker, and we'll see number of rows in component. That's the method we want. So that's the only method there. That's the only one we want. And we're just going to return, now this for the rows, we're going to return the number of items in our people array. So we're going to return main delegate.people count. So however many items there are in the people array, that's how many rows we want in the picker. So that's the first method. The second method is how many columns, like I was just trying to describe. So this is also an NS integer return type. But oddly enough, this doesn't require us to type in the word picker. We can just simply start typing in the method by saying number of components in picker view. All right, so a bit of a takeaway from what we're used to, where we actually have to type the word picker to get the method name, but here we just start typing in the method name and we get the picker method we want. So we only want one column in this implementation, so we're going to say return 1. Right? So those are our first 2 methods. Now, the next method, the third method is, you might guess, it's like, what does each row look like in the picker? Now, in the table, it was pretty complicated to do that, right? In the picker, not so. It's very simple and straightforward. So it's an NS string return type. So we're going to create a new method down here, NS string. Start typing in picker, and you only have the one method again. So very simple. Title for row. Question is, what do we want to put as the title? We'll stick to name. So we need the name here. Now, for us to do that, our people array, we have to pull out an object from our people array and extract the name from that object. So we need to have access to data.h. So we have to actually, at the top of the file here, import data.h. So once we bring in data.h, now we can actually use the data object. So we can go back here, and we'll say data, call it person, is equal to, and we'll say main delegate.people, object at index row. Now notice there's nothing called index path here. Unlike the table, we had index path and inside of it had the row number. Nothing complicated like that. It just passes in an int, an NS integer called row, into the arguments already. So we already got our row number. We don't have to worry about anything here. All right, so we have our row, and we have to return the name. So we're going to say return person name. So we're just going to return the name. We could return email, could return food, whatever we want, but we'll just pick name for this implementation. All right, so those are the 3 methods. This is enough to get the picker up and running. But one of the things we wanted to do was have an event handler built into the picker so that when I select something, it automatically did an operation. In our case, do an alert box. So that's all we wanted to do here. So to do that, we're going to have to add another method. So it's a void return type. We'll start typing in picker, and it's did select row. So you notice how there's only a handful of methods here, in fact, one per return type. So it's very simple here. So for this, we want to have our alert box come up. So it gets a tiny bit complicated here, but not that much, right? So the only real heavy lifting we're doing here is the alert box. So first thing is, let's get the person object out again. So we'll say data person is equal to main delegate.people object at index row, and we want to have our title for the alert box be our person's name, the message for the alert box be the person's food. So let's define a couple of NS strings here. So we'll say NS string, and we'll say title is equal to person name, and then NS string MSG is equal to person food. All right, so all that's left now is to define our alert box and get that alert box to display. So let's start by defining our alert controller. So we're going to say UI alert controller, and we'll call it alert is equal to UI alert controller, and we'll say alert controller with title. So first argument is title, which will just pass in the title string we just created. Second one is the message, so MSG. Third one, preferred style. So we're going to say UI alert alert controller style alert is what we want. So that's our alert box that we're going to start with. The next step for the alert box is to define a button. We're just going to have a simple OK button for this, right? Just like in the table that we did in the last time around. So we're going to define our alert action here. So we'll say UI alert action. Just call it OK. It's going to be a simple OK button is equal to UI alert action. Call it action with title. So the title will just be OK. Style will be UI alert action style default. And handler will be nil because we don't really care about what happens when the person hits the OK button. We really just want the alert box to disappear, which it'll do, right, when we hit the OK button. Right? So that's what we want. Next step is to add the OK button to the alert box. So we're going to say alert, add action, OK. Last step, make this all happen, make it display. So we'll say self present view controller, passing in alert. Yes, we want it animated. Completion handler will be nil. We don't really care about anything happening upon completing this. If you want to have some special code execute upon clicking on the OK button, sure, you could add that here too. So that's the idea behind it. Now you have enough code to get the picker to work. So we'll jump over to main storyboard and connect up the picker as well as data source and delegate for that picker. Or should I wait? Keep going? Okay. I'll wait for those footsteps to go. Nobody wears slippers anymore, huh? All right, so go over to the picker. And first I'll highlight the yellow circle. I will look for my picker, connect that up. click on the picker, and I see data source and delegate. I want to do the exact same thing I did with the table. Connect that to the yellow circle or view controller. All right, so there's one, and there's two. So now you can run this thing. And we should see the same data we saw in the table in the picker now. So we have our loading screen. There's our home page. So view database using picker, we should see all of our people here. If I choose any one of them, right, I should see the alert pop up. And that's the picker view. All right, the last part now is to get this save button up and running. Now to get this save button up and running, we need to create a method to insert a row into the database. So we want to insert name, email, and food into the database itself. So for that, we have to jump over to appdelegate.m and add another method. So I'm going to stop running here. We're going to go over to appdelegate.m. We're going to create one more method. So we have here check and create database, and we did read data from database, which we saw some really complicated C code, not Objective-C, but C code. And we actually mixed some Objective-C with C, which got really confusing at some point. But now we're going to jump into our final method to insert. And of course, you can create a method to delete, you can create a method to update as well. But in our implementation of this table here, we didn't really care too much about the ID in the table. But if you were to take this a step further and do an update and delete, in your data.h, you want to add an int that will be your ID. And then you want to save that into the data object, so for the people array. So you want to keep track of the ID number so you can do your update and delete. All right, so that's feature expansion for your app here. But what we're going to do now is create a new method. Now this will be a bit of a breakaway from the type of methods we've been doing for this code. We're going to do a bool return type. So we're going to say bool, and we'll say insert into database. And we're going to pass in a data object. So we'll say data star person. Now the reason we're doing the bool is because we want to see if this insert actually happened. And if it failed, we want to put up an alert box on the user's screen to say, hey, it failed. And we're going to use the bool return to actually determine whether this passed or failed. And we're passing in, we have two options. We could have passed in name, email, and food individually, but that's a bit of a headache. So why not just pass in a data object instead, making it easier for us. So what we're going to do is we're going to start off by defining our SQLite 3 database object. So SQLite 3, say database. And then we'll define our return code. So we'll say bool return code is equal to yes. Now, starting off with this, what we should do now is actually recap what we did last time around with the read data from database method, just to get an idea of how we did things, because we're going to take a very similar approach to this method that we did in the read data from database method. But it is confusing. So we're going to take a moment and we're going to look at that here. So in read data from database, we emptied out our people array. We created our database object here. Even though it's in C, it's really a struct. First step was to open a connection to a database. So we opened a connection. Next step was to prepare our query and define an object called compiled statement, which would be our manager for the query. So you see the database variable of SQLite 3 type, this managed the connection. This other object, SQLite 3 statement, manages the query. So it's gonna have the query inside of it. It's gonna request the query be done to the database, and then it may have data sent back to it. So in this select case, it's sending back all the results of the select inside the compiled statement variable. in our insert, we're not going to really have any data to return, but we're still going to use it. We're still going to use the compile statement object, and we're going to have maybe return codes return back to us, maybe an insert ID, something will return back to us. But that's the idea. And because we're doing a query, we're going to go ahead and use the step inside a while loop and go ahead and run this. So the prepare v2 above it, it actually prepares the compiled statement object to be instantiated, and well, it's C, so we don't instantiate, but really malloc the memory for it, and just attach the query to it. The step actually goes ahead and makes it happen, right? So it's going to continuously run the query until there are no more rows to return. And then from here, we took the data inside each row, so name, email, and food. We pulled it out of the row, saved it as a character string because, again, we're dealing with C, so we don't deal with NS strings just yet. We need to convert that C string into an objective C string over here, and then we have ultimately saved it inside a data object and added it to our people array. And that was our query. Then we just ended off by freeing up all the memory that was allocated to us for the query and for the object itself, and then closing our database connection. So those are the steps involved in getting the database to query and getting data back from the database. Now for inserting into a database, we're going to take a similar approach, but because we're inserting stuff, we'll deviate just a little bit in certain areas. So going back to our method insert into database, we start off by defining our database variable. We have a return code. Now this time around things should work pretty smoothly because we got all the bugs out of trying to connect to our database in the previous method. So it should be okay now. So we're going to start off with our if statement to open our database connection. So we'll say if SQLite 3 underscore open, and we're going to pass in self.database path, converting it to UTF-8 string. And we're going to pass in the memory location of the database variable. So ampersand database. Now we need to check to see if that's equal to SQLite underscore OK. Right? So our first step is to open a connection to the database. All right. Next step is to generate our query. So we're going to use a C string again. So we'll say char star, call it SQL statement. Again, it's not an objective C string, so we'll just use double quotes here. And we're going to define our insert here. So we're going to say insert into entries, which is the name of our table, values, and inside of our round brackets, things will be a bit different from what we're accustomed to. So the first thing is like we did in our when we were creating the database at the command prompt, we're going to start off with null because we want to trigger that auto increment. So that first column, the ID column, we want to trigger the auto increment. So we're going to say null. All right, so that works there. Now the next three, there's really no string joining in C. So there is, but we're going to take a different path here. We're going to put for all three variables here, we're just going to put question marks. And we're going to use another function to insert that data for us. So we're going to say null and then comma question mark, and question mark. All right. So we're going to replace these question marks in a moment with the data, our name, email, and food. Right. But we're going to take another function, another C function, to do that for us. And the next step is to define our compile statement object. So we're going to say SQLite 3 underscore STMT. We'll call it compiled statement. So now we have to prepare our compiled statement object, allocate memory to it, attach the query to it. So we're going to say if SQLite3 underscore prepare v2. And so our first argument is the database. Second argument is SQL statement. Third argument is -1 because we don't know how much data will be transferred. So we'll just say -1 and let it figure it out. Next argument is compile statement, the memory address compile statement, so ampersand compile statement. And last one is null. Not nil, but null. We'll check to see if that's equal to SQLite underscore OK. So we're using the prepare statement to basically allocate memory for compile statement, attach this query inside compile statement so we can get ready to execute it. But we can't execute it just yet, because what we need to do is replace those question marks with our variables name, email, and food. Right, so we have to do that now. So we're going to use a C function that'll do that for us. So we're going to say SQLite3 underscore bind. And if you look at, without finishing this function, there's bind blob, bind double, bind int, bind null, bind parameter, bind text is what we want because we're dealing with just text here. Not 16 or 64 because there's 16 and 64-bit, but just bind text. And so first thing we pass into bind text is compiled statement. Second argument is the column number. So remember, column 0 was our ID, column 1 is name, column 2 is email, and column 3 is food. So I want column 1 for name. The next one is the person, from the person object, I just want, from the data object, I just want the name. But I have to convert it to a C string because right now it's an NS string. So we're going to open up a square bracket and say person.name UTF-8 string. All right. So person.name UTF-8 string, that converts it from an NS string to a C string. Right. Next argument is the column number, or sorry, not the column number, number of bytes. We don't know how many bytes this will require, so we'll just say -1. Last argument is what type of transaction. So we'll type in SQLite underscore transient. There's transient and transaction. We just want transient. So that attached the person's name variable to the question mark. So this question mark here is now being replaced with person name. So this. So now we have to do the same thing for the other two question marks, which is email and food. So I'm just going to copy and paste this because it's actually almost identical code. All right. So we have SQLite3 bind text, compile statement. Now we're dealing with column 2. Column 2. And then person.email. And then the third one, column 3. And then person.food. Okay, so we have now attached and replaced the 3 question marks with name, email, and food with these 3 lines of code. And so if you're inserting an int, then you would use bind int. If you're inserting a double, you can do the same thing. So you have the different bind functions depending on the data type that you're inserting. All right, so once we have the variables attached, we're almost there. What we're going to do is now we're going to execute this query. But we're going to do it inside an if statement again. So this prepare statement, we're done with it. Let's go below it and do another if. And what we're going to do is we're going to run this query, this insert, and we're going to check to see if it was successful. So we're going to say if, and we'll check to see if it failed actually first. We'll check to see if it failed. So we'll say SQLite 3 underscore step, passing in compiled statement. Now, if this does not equal SQLite underscore done, so if it doesn't equal this, it means it failed. If it successfully did the query, it returns back SQLite underscore done. Okay. If it didn't, we should post an error message, right? So let's say nslog, just so we can see it in the console, see what error message came up. We'll put in like a message like error with a %s. And call another function that is SQLite 3 underscore ERMSG, passing in database. That will return back the last error message that the database triggered. Right? So whatever error message is the latest one gets sent back. That's assuming that this transaction failed and it didn't return SQLite underscore done. But we also want to check to see if it succeeded. So we'll just say else. Question is, what do we do when it succeeded? Well, at this point, there's not much we really need to do, but for our own sanity, in the console, let's return back the ID number that was triggered from it. So the latest ID from the newest row. So we'll do another nslog, and we'll say insert into row ID equals, and then do like a %d, but this will trigger a warning, and we'll fix that. So the argument for %d will be SQLite 3 underscore last insert row ID, passing in database. So this will return back the last insert, the row ID for the last insert that was done, which is this. Now this is triggering some sort of issue, and that's because this returns a very large data type, not an int, but a long, or even a long. So it's looking for an LLD, %LLD. That's the type it's looking for. All right. At this point, we're basically done. Let's do some cleanup. Oh, but before we go ahead, though, inside this if statement, we missed one step. So here, if we hit an error, there's one thing we have to do. Now, we have a bool return type for this method, right? We have return code. Return code is going to be assumed yes, meaning that it's going to assume it's successful until we tell it it's not successful. So at that if block, we actually have to tell it it's not successful. So we're going to say return code equals no. All right, so we have to do that. Now we can actually clean up and finish up everything here. So we're gonna do a little finalize here. So we're gonna say SQLite 3 underscore finalize. This will clean up all the memory for a compiled statement that was allocated to it. So any memory that was allocated to it, anything related to the query, anything that was allocated in terms of memory is cleaned up now at this point. And then finally, we're going to close up the database connection. So we'll say SQLite 3 underscore close, passing in database. And finally, we've got to return the return code. So return code. And now we're done with this method. So it's pretty messy in terms of coding. But when you look at the steps, it's not that bad once you understand the syntax behind it. So we'll recap from the top. First step is to define our database, set up a return code. We're going to assume it's successful no matter what until we're told it's unsuccessful. So first step I was going to do is we're going to open the database connection. Next step is define our query. Next step is to allocate memory to the object that will manage our query, manage our results for the query. So SQLite 3 underscore statement, compiled statement. So using prepare v2. Next step is to take our variables, name, email, and food, attach them to the query. So replacing all of the question marks with name, email, and food. Next step is to execute the query, check for if any errors occurred. If it did, tell us the error. Otherwise, tell us the latest row ID that was inserted. Next step is to clean up any memory that was allocated to compile statement, and finally close up our database connection. So that's essentially what happened there with this method. Okay, so now that we're done this method, we need to take this method declaration and put it inside our header file. So I'm going to take the method declaration here, copy it, paste into appdelegate.h, put a semicolon at the end of it, and there's a problem. It doesn't know what data is. So we included data.h in the M file, but it's asking us to include it here. If we do this, include data.h here, we're including it here, and we're including in the M file, which is not a good thing, because if we're doing a site, this is kind of like a circular include. We're including in the H file, and then we're going to include it again in the M file, but we also include it in the H file, so it gets brought over by default. So it gets really confusing to the compiler. So our best bet is to go into data.m and take out the include. So we have here import data.h. We're going to take that out. So now, because we imported appdelegate.h, it's going to bring in data.h for us. So we don't worry about that circular include anymore. Okay, so we have our method to do an insert. So let's go ahead back to viewcontroller.m and actually finish this thing off. So actually I'll start off in the header file and we'll just recap what we have here in viewcontroller.m. So in the first part of the app, we actually created our text field variables, tb name, email, and food. We attached them to the three corresponding text boxes, and we also synthesized as well. So we synthesized them, so we got them out of the way. The text field should return to get rid of the keyboard, so we did that already, took care of that already. And now our last step is to create an event handler that'll handle the save button and actually insert into the table. So we're going to create a new event handler. We'll call it add person. So we're going to say IB action, add person. First step is to define app delegate. So we're going to say app delegate, and then main delegate. And we'll notice that that's an issue. So we actually have to bring in appdelegate.h. So import appdelegate.h. But the data object is brought in from the appdelegate file already, so we don't have to worry about bringing that in. So let's finish off defining this. We'll say it's equal to appdelegate star, and then UI application, shared application, delegate. All right. Now let's create a data object here by pulling up name, email, and food out of the text fields. So we're going to say data, call it person, is equal to data alloc init with data. And here we're just going to retrieve the text from all three text boxes. So for the name, we'll just say tb name.text, and then tb email.text, tb food.text. So now we have our we have our person object. All I have to do now is insert into the database. So let's say bool return code is equal to main delegate insert into database and pass in person. At this point, we're done. We're done with this app. We could just connect up the event handler and be done with it, but we have a return code here. Let's actually put up an alert telling us either way. Did it succeed? Did it fail? Let's give the user some feedback here with an alert box. So we'll start off with defining a string here. So we'll say ns string, and we'll call it return message. Set it equal to. We'll say person added. That'll be our success message. And then we'll check the return code. So we'll say if return code equals no, we'll change that return message to fail. So we'll say return message is equal to person add failed. So either way, we have our answer. Did it fail or did it succeed? So let's go ahead and put up an alert box that'll tell us either way. So we'll say UI alert controller. We just call it alert. It's equal to UI alert controller. And we'll say alert controller with title. Our title will be SQLite insert. Our message will be return MSG. Preferred style will be UI alert controller style alert. Next step is to create an OK button. So we'll say UI alert action. We'll call it OK again. So we'll do an OK button. It's equal to UI alert action. We'll say action with title. And we'll pass in the OK as our title for the OK button. The style will be UI alert action style default. Handler will be nil. We don't care about any event handler upon clicking on the OK button. Now we gotta add the OK button to the alert. So we'll say alert, add action, OK. And then finally, last step is to make it happen. So let's get this alert box to pop up. So we'll say self, present view controller. We'll pass in alert. We'll say yes, we want it animated. And nil for completion handler, meaning we don't care about anything happening upon completing it. And we're done. We just have to connect up this event handler to the save button. Alright, so let's finish off this app by joining the event handler inside main storyboard. We'll go back to our home page. Click on the yellow circle. Look for add person. Join that to our save button. Use a touch up inside. And now we're done this app. We can launch this and verify that everything's working. Right, so just to look at the entire app from scratch, we have our table, right, and it's fully functional. We have our picker, it's fully functional. Now, last step, let's insert something in here. So, I'm just going to toggle the keyboard. All right. So I'm going to say Luke Skywalker. We'll say Luke at skywalker.com. Let's say his favorite food is cookies. Hit save. It says SQLite insert person added. We'll hit OK. Let's look at our console. We see insert into row ID is 5, so it did succeed. It did give us an ID number, right? And we can finally verify this by going into, say, our table, and we see Luke Skywalker down here in the list. We see Luke Skywalker likes cookies. You can even, if you really want to be sure, you can go to the picker, verify. There's Luke Skywalker. He likes cookies. And so now this brings the end to this app. Just to recap what we learned how to integrate a SQLite database into an app. We learned how to write the C code that is involved in getting the data from the database and also inserting data into the database. And you can take this a step further and write a couple more methods, one for delete, one for update. But you'll have to modify the data object, data.hnm, to incorporate a new variable, an int, for the ID number, right? Because you're going to delete and update based on ID number. And we also looked at touch events. So on the home page, there's the two labels here. These are labels again. These aren't buttons. But we learned how to do touch events so they can touch any part of the screen, figure out the XY location on that screen of what was touched, and we have an event happen based on that. And that event in our case was to execute a segue in code. So we learned how to execute a segue in code. And finally, we learned how to use a picker, how to define a picker, how to also do an event handler for the picker, and we found that it's a lot simpler to do than a table.